Matter in our surroundings, states and properties. Ever wondered what everything around you is actually made of? Why does ice melt? Why can you squeeze a pillow but not a rock? And where does a puddle go on a sunny day? The answers lie in understanding matter itself. In this series, we'll explore what matter really is, why it behaves the way it does, and how temperature and pressure can change everything. What is matter? Matter is anything that has mass and occupies space. You see matter all around you, your desk, your water bottle, the clothes you're wearing, and even the air you breathe. But here's the interesting part, sometimes our five senses can't directly detect matter. For example, you can't see air, but it definitely has mass and takes up space. Matter is made of particles. These particles are incredibly small, so small you cannot see them with your naked eye. You can actually observe this using a simple experiment. If you dissolve sugar in water, the sugar particles spread throughout the water until the solution is evenly mixed. And here's the key insight. Between these particles, there are spaces, empty space filled only with forces and the vacuum of nature. Particles are never still, they are continuously moving. Even in solids, where you might think everything is frozen in place, in gases, you see this effect clearly. When perfume is sprayed in one corner of a room, its particles spread throughout the entire room. This is called diffusion. But particles don't just move independently, they attract each other through forces called intermolecular forces. This attraction keeps matter together and gives it its properties. Let's start with solids. A solid has a fixed shape and a fixed volume. No matter what container you put it in, a solid keeps its own shape. Solids also have high density because their particles are tightly packed together with very little space between them. The particles in a solid are held in place by very strong intermolecular forces. They can only vibrate in fixed positions around their equilibrium point, like they're held by tiny springs. Now let's consider liquids. Unlike solids, liquids have no fixed shape. They take the shape of whatever container you pour them into. However, liquids do have a fixed volume. The amount of liquid stays the same even though its shape changes. In liquids, particles are still close together but not as tightly packed as in solids. They have moderate density and the intermolecular forces are weaker, allowing particles to slide past each other while remaining in contact. Finally, let's look at gases. Gases have neither fixed shape nor fixed volume. They expand to fill any container completely, no matter its size or shape. Gases have very low density because their particles are far apart with lots of empty space between them. In gases, the intermolecular forces are very weak, so particles move completely freely and randomly throughout their container, colliding with each other and the walls. Temperature has a profound effect on matter. When you heat matter, you increase the kinetic energy of its particles, causing them to move faster. This increased movement can cause matter to change states. A solid heated enough becomes a liquid, and a liquid heated enough becomes a gas. And cooling reverses this process. Cool a gas and it becomes a liquid. Cool a liquid and it becomes a solid. Pressure also affects matter significantly. When you increase pressure on a gas, you squeeze its particles closer together, reducing the space between them. With enough pressure, a gas can transition directly into a liquid without changing temperature. This is how liquefied petroleum gas or LPG works. When you open the valve of an LPG cylinder, The pressure drops suddenly and the liquid instantly converts back to gas, which is why you feel cold when gas escapes. Matter can change between states in 6 different ways. Let's create a complete picture of all these transitions. From solid to liquid is melting. From liquid to solid is freezing. From liquid to gas is boiling. From gas to liquid is condensation. But there are two more transitions that bypass the liquid state. Sublimation is when a solid converts directly to a gas, and deposition is when a gas converts directly to a solid. Every pure substance has two important temperature thresholds. The melting point is the temperature at which a solid becomes a liquid. The boiling point is the temperature at which a liquid becomes a gas at atmospheric pressure. These points are characteristic properties of pure substances, meaning each pure substance has its own unique melting and boiling points. This helps us identify what substance we are looking at. Here's something fascinating: when ice melts, it absorbs a lot of energy, but the temperature stays the same at 0 degrees Celsius during the melting process. This energy is called latent heat of fusion. The energy doesn't increase the temperature, instead it goes into breaking the strong bonds holding particles in fixed positions so they can move more freely as a liquid. This is why ice at 0 degrees Celsius actually cools better than water at 0 degrees Celsius. The ice absorbs more heat energy from your body through this latent heat of fusion. Similarly, when liquid boils and turns to gas, it absorbs latent heat of vaporization, and again the temperature stays constant during the boiling process. This energy breaks the bonds between particles so they can move completely freely as a gas, separated by large distances. And here's why steam burns are much worse than boiling water burns. Steam carries the latent heat of vaporization on top of the heat at 100 degrees. When steam touches your skin, it releases all that energy at once. Evaporation and boiling might seem like the same thing, but they're actually quite different. Evaporation is a surface phenomenon. It happens only at the surface of a liquid. Boiling, on the other hand, is a bulk phenomenon. Bubbles form throughout the entire volume of the liquid and rise to the surface. Boiling only occurs at the boiling point of the liquid. Also, evaporation can occur at any temperature and actually cools the liquid because the highest energy particles escape first. Boiling produces no cooling effect because it only happens at a fixed temperature. The rate of evaporation depends on several factors. First, surface area. A larger surface area means more particles can escape at once, so evaporation is faster. Second, temperature. Higher temperatures give particles more kinetic energy, so more of them can escape. This is why wet clothes dry faster on a hot day than a cold day. Third, humidity. Low humidity means fewer water molecules are already in the air, so more can escape. High humidity slows evaporation because the air is already saturated with water vapor. Finally, wind speed. Moving air carries away water molecules, making room for more to escape. This is why clothes dry faster on a windy day. So now you know matter is everywhere around you. It has mass, it takes up space, and it's made of tiny particles constantly moving and interacting. If you found this helpful, smash that like button, subscribe for more science, and drop a comment telling me what surprised you most about matter. Thanks for watching, and I'll see you in the next one.